All right, let's do it. Step one, let's find the amplitude and period. So let's find amplitude and period. I like how Velasquez is thinking. I know Nunez is thinking that too. As I pass them up, he's already trying to find that out. Let me get my graph ready here. Here we are. No. That's not what I need. Is that the one? Oh well. Let's use that one. Okay. So let's go back over here. So find amplitude and period. Nunez, what's the amplitude formula?
This is A.
No more specific though for me.
Absolute value.
Absolute value of A. Okay, so let's compare this, cicados, with standard form. Y is equal to A sine Bx, yeah? So my A value is 6. My B value is whatever is in front of the X. In this case, it's 2. So the amplitude then, ready? Here we go. Well, we graph it. The amplitude is going to be the absolute value of 6, which is a 6. Cool. Period. Connor, what's my period formula?
2 pi over the absolute value of B.
Beautiful. 2 pi over absolute value of B. This is always going to give us a period. So Velasquez, remember you're guessing it? That's what I was telling you close. Look what happens. 2 pi divided by what's B?
2.
2. So what's 2 pi divided by 2? 1 what? 1 pi. Or 1, yeah, 1 pi. So pi is actually our period. So for one cycle to take place, it's going to take just a period or pi radians for one complete cycle to finish instead of 2 pi like the one. So check this out now. So let's go to our graph. I'm going to make a y-axis. I'm going to make an x-axis. So look what I'm going to do. I'm only going to create one cycle, so I'm just going to go one period long. I'm going to chop it up into 4 pieces. 1, 2, 3, 4. This is going to be pi. That's the end of my period. So I chop up into 4 pieces and end with the period for my graph. Because one period will be pi units long. And the amplitude was 6, so I'm just going to go by 2s here. 2, 4, and 6 is up here. -2, -4, -6. Do that with me? Question so far? All right, we got our amplitude, we got our period, and now, what are we going to find now? You guys remember? 2 days ago?
X-intercepts.
The x-intercepts. In other words, we're going to find our 5 key points. Right here, the 5 key points on this handout. And the guide is right here. It's just a matter of plugging and chugging into this guide. Are we dealing with a sine function or cosine function? We're dealing with sine. So I'm going to use the bracket that has all the sine stuff. The sine has 3 x-intercepts, 1 maximum and 1 minimum per cycle. Okay? Questions so far? Good. I don't feel like answering any questions. So here are 5 key points. Let's start off with the x-intercept. So x-intercepts, where does this graph cross the x-intercept? Well, the x-axis rather. For sure 0, 0. That's the first one. That's easy. Let me go to my graph then and plot 0, 0. Do that with me. Easy. Look at that. There's 0, 0. That's an x-intercept. Okay. Next x-intercept is going to be at 1/2 the period. Okay, I put 1/2 p. P is equal to means period. And I put that in a little cloud here, just to remind you that a means amplitude, p means period. So 1/2 the period, 0. Okay. What was the period again? 1 pi. Amplitude is 6. So look what I'm going to do. 1/2 times the period. 1/2 times pi. What's 1/2 times pi? Well, it's just pi over 2, right? Because pi over 1. 1 times pi, so it would be pi over 2. So it'd be pi over 2 is my x coordinate, and then 0 would be my y coordinate. So let's come back over here. Now, here's pi. That's the end of the period for 1 cycle to occur. I chopped it up into 4 pieces. If this is pi, this would be pi over 4, right? Look at from here. Because this is 1/4 of the way. 1/4 times pi would be pi over 4. 1/2 of the way would be pi over 2, yeah? 3/4 of the way would be 3 pi over 4. Think about it. 1/4 of pi would be pi over 4. 2/4 of pi is pi over 2. That's half pi, right? 3/4 times pi. Well, what's 3/4 times pi? Look at 3/4 of the way. Look at 3/4 times pi. I'll do the work right over here. 3 times pi is 3 pi on numerator. Denominator is 4. 3 pi over 4. Look, that's 3/4 of the way. So you always get your period and chop it into 4 pieces. Okay, so let's graph that second x-intercept. That second x-intercept was right here, pi over 2, 0. Right here, pi over 2, 0. There's your second point. There's one more x-intercept, right? What's the third one that says the guide? What does P stand for? Period. There we go. P and then 0. The period is 0. What was the period? Pi. So pi 0. Look at the third x-intercept. Pi 0. Do that with me. Pi 0. Pi 0 is right here. There's our x-intercepts. They're covered. Tell them they're covered. Text them together. Here we go. So we're done with the x-intercepts. Now let's find the maximum right here. There's only one point that's a maximum, right? According to our guide, the maximum is 1/4 the period. 1/4 the period. Then the amplitude. Our maximum point. The highest point, the peak. The peak will be at 1/4 the period and the amplitude. Okay, let's do it. 1/4 the period. We found the period way back in step 1 was pi, right?
Pi over 4.
It'd be pi over 4, huh? So 1/4 pi, and then the amplitude was 6. Let's simplify. 1/4 pi is just pi over 4, right? 6. Let's plot that point. There's your maximum point. Pi over 4, 6. I trust I'm not going too fast. So let me go back to our graph paper. Pi over 4, 6. Pi over 4, 6. And our minimum point now, right? That's the last point, the 5 key points. 3 x-intercepts, a maximum is the 4th point, the minimum will be the 5th point. And let's look at our guide. The minimum is 3/4 the period.
Negative 8.
And negative amplitude, huh? Whatever the amplitude is, take the negative of that. That's going to be your minimum. What was the period, Helena? Pi. So get 3/4 pi. And then the amplitude, what was the amplitude again? So I'm going to make it -6 now. 3/4 pi, which is really, if I multiply this out, it's 3 pi over 4, right? This becomes that. And then -6 and plot that. 3 pi over 4, -6 is right there. Cool. All right, let's create our cycle now. Sine function. Coming up to the peak, coming down in the curve, x-intercept to the minimum. There's one complete cycle, the sine function. It's one cycle. Do that with me. Of course, it keeps going over and over the cycle, but we graphed one cycle. It's repetitious. Remember, as that angle keeps going around and around in revolutions, this is going to keep doing that forever, as long as you stop turning that angle. Tomorrow we'll practice cosine function for the quiz, maybe. Now, I'm going to put you guys up into 2 teams. Nunez, Herrera, Mulder, Cano, Cicados, Velasquez. Velasquez, you're the team leader here. Nunez, you're the team leader here. So Bolden, right here, sit next to Nunez, and Herrera, get your desks together, somewhat together. And Cicados, Velasquez, and Cano, put your desks somewhat together. Velasquez, think of a team name. And Nunez and Cano. Actually, you know what? Herrera, you've been here. Cano, you come over here. Herrera, you're going to be with Velasquez. Because you've been kind of absent, I want to get the team a little even here. So you've been here, he hasn't been here. Velasquez has been here. Yeah, so that's nuts. You two have been here, he hasn't. You two have been here, he hasn't, so make it a little even. Staccato, so have a little politeness and at least pretend to contribute, man. Come on. All right. Here we go. Okay.